My name is Nicole Willette, and this is my pseudocode portion of the project. So for this project, we're going to give our user multiple options to choose between A, B, C, and D, depending on the result they want from the matrices they input. So for our choice B pseudocode, we're going to begin our implementation the way we usually do. We're going to have a header that needs to be declared along with main function and variables, including your matrix A, matrix B, rows for A, rows for B, columns for A, columns for B, and integers I and J. Next, you're going to need a series of printfs and scanfs to request and collect information from the user. This starts with simply asking for the row and column sizes of each array and saving these as row and column variables. A do-while loop will be created with a conditional that columns for A do not equal the number of rows for B. If this statement is true, the user will be prompted to retype row and column numbers. If it is false and the user gave correct input, the loop will be broken and the code will move on. A nested for loop needs to be created for each matrix with your rows as the outer loop and columns for the inner, ranging from 0 to the inputted size for each. These loops will prompt the user for specific numbers for each matrix location. Moving on to the actual matrix multiplication. A new matrix array for the product and a k variable need to be created to compute the result. A nested for loop needs to be created to cycle through rows and columns while multiplying. The innermost loop will multiply specific elements by changing the column of A and the row of B each loop. Within this innermost loop, the product matrix will be set equal to the prior product matrix value plus the matrix A element times the matrix B element. The middle loop will reset the product matrix to 0 and move the code over to the next column of B. The outermost loop will then move down a row in matrix A. Finally, a nested for loop will be used to print the resulting product matrix. So if our user instead decides to go with choice D, our overview for that one is going to be requesting elements of matrices A and B. Then we're going to find the determinant of matrix A. This is going to be our variable D. Then we're going to find the determinant of A, where B replaces the first column of A, which is going to give us our variable dx. Then we're going to find the determinant of A, where B replaces the second column of A, giving us our dy. Then we're going to find the determinant of A, where B replaces the third column of A, which is going to give us our dz. And then finally, we're going to divide the final three determinant results, each by the initial determinant D, to identify x, y, and z. So getting a little more into detail for that choice, our implementation is going to include a nested for loop that needs to be created for each matrix with your rows as the outer loop and columns for the inner loop, of course, ranging from 0 to the inputted size for each. These loops will prompt the user for specific numbers for each matrix location. I will be creating a user-defined function to calculate and return determinants in accordance with the instructions. So since the code will only be working with 3x3 matrices, I have decided that I will be writing out the full determinant equation with specific array elements rather than using a for loop, which I feel leaves more room for error in the function. I plan to create a new matrix for each determinant calculation. I'm going to do this by assigning values accordingly for matrices A and B to each new matrix so that the determinants line up with dx, dy, and dz. I will then use each matrix as an argument for my determinant functions. After applying the determinant function to assign values to the variables d, dx, dy, and dz, I will finish out Cramer's rule in the main function by dividing dx, dy, and dz by variable d and printf will be used, of course, to display the results. Thank you.